Hi everyone, my name is Abel Greykantoma. I'm from GREYTEST CAD Design Concept. This is actually my WhatsApp contact. You can reach me on this number or you can call me, okay? These are the list of softwares which we have covered on our YouTube channel. They are very much available on that channel. Visit that channel and actually keep yourself busy, okay? We have covered structural designs and detailings, road designs, water designs, mechanical and electrical service drawings, and architectural working drawings. All these tutorials are very much available on our YouTube channel. Down below the description of this video you'll find a link to that channel. Visit that channel and actually keep yourself busy, okay? We now teach all of the softwares on our Telegram platform, where we'll give you the software, we'll guide you on how to install it and how to crack it on your system yourself, okay? For 40 days just for a token, okay? You come register with us, you can DM me or you can even call me, okay, for more information about our trainings. Today I'll be taking you through Etabs. This is actually series. We have covered a very wide range of designs using Etabs. If you go down below the description of this video, the link to that channel, you'll find these tutorials on Etabs which we have covered. Okay, today I'll be taking you on a series on Etabs. Okay, let's jump right into it. Now we're going to be using Etabs version 19. Okay, now I'm going to file and I click on new model. Okay, as you can see, we have use saved user default setting. We are going to use the built-in setting. Okay, now you can see the display unit. You can switch your unit to US customary. It's actually in feet, in inches and pounds. Okay, but I'm going to be using the metric SI, okay, which is actually in millimeters, meters, kilometers. Okay, now still section database. You can choose any of these templates here based on the code of practice which is actually used in your country. So I'm going to be using BS, and then the still design code, I'm going to be using BS 5950 part 2000. Okay, so the concrete design code, I'm going to be using 8110. So you can choose any of this design code. These are templates, okay, based on your code of practice in your country. I click on OK, close this. If you already like what you're seeing, make sure you like this video, okay? Give it a thumbs up, okay? Subscribe to this channel, it's 100% free. Click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly basis, sometimes on a daily, so as to encourage as many that actually wants to have a deeper insight of design. Okay, now these are all structural objects. You can see for flat slab with perimeter beams, for waffle slab, for two-way and or rib slab. Okay, today we are going to be actually designing this. Sorry about this. We're actually going to be designing this. Sorry about this. Okay, sorry, my line is not straight, so I'm going to make it more straight. Okay, so let's say we have a hinge support here, then we have a roller here at the middle, and then we also have a hinge here. Okay, and then from here to here, let's see, here we have 6 meters. Here we also have 6 meters. Okay, and then at the midpoint here we have 10 kilonewton, and then let's see, from this point to this point. Okay, here we have 2 meters here. Say I cover 2 meters here. Okay, so this is actually the point load. So this is not at the middle. Okay, so from here to here is actually 2 meters. Okay, okay, so if this is our grid here, let's say here we have I'm going to be having something like this. Okay, this is a grid, just like your axis, creating an axis for this, and then we have one that goes this way. So if this is A, for example, you have your B, you have your C, and then this is 1, this is 1. Okay, so this is exactly how we are going to be specifying these grids in our Etabs. So this is the beam we're actually going to be designing. This beam is actually with 2 span, as you can see, one here, one here. Okay, at 6 meters, 6 meters. Okay, so this is your A, this is B, this is C. Okay, so we have a load here, a pointed load here, we have another concentrated load here. Okay, so let's go into that. Now I'm going to be using custom grid spacing. The uniform grid spacing maintains an equal spacing. As you can see, the number of grids we have 4 along X, along Y also we have 4, and then the spacing in between those grids are 8 meters. So we are actually not going to be using uniform grids space, but we can as well use this. But for the sake of this tutorial, I'm actually not going to be using this. I'm going to use the custom grid spacing, and then I click on edit grid data. Now here you can see we have if this is actually our origin, so at this point here is 0 because this is actually our starting point. From here to here now is actually 6 meters. Okay, so this is 6 meters from here to here, and then from here down to this place is actually 12 meters. So if that is correct, if I'll highlight on this, we only need 3 of those grid here, which we have here. We have 1, 2, 3. So I'm going to take one of these off, so I'll delete this. Then here I'll edit this, make this 6, and here I'll make it 12. Okay, do you want it visible? Yes, 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 we want all of them visible. All our grids are actually going to be visible. So when you come down to your y-axis, you can see from here we only have one here. Okay, so we are actually going to be using one of these grids here. We only have one grid along this. Okay, so I'm going to take off every other grid here. I'll delete this, and then now if I click anywhere around this window, you see now it has updated this diagram. You can see this is actually looking like what we have here. Okay, good. So we can see the bubble size. I can actually change the size of this bubble. The grid color can also be changed. I can change the color of this grid. You can see it has actually changed to this color. The size of this bubble, I can as well change that to 1500 if I want to, or I can leave it as default. So if I click anywhere in the screen, you can see the size has actually changed as well. The reference points, we're actually going to be using these and these reference planes when we are dealing with a real building project. Okay, so we are going to be doing some building designs later on in this series. Okay, the grid system name, I can actually change this to whatever name that suits me, but I'm actually going to maintain this just as it is. Okay, so right now I'm going to click on OK, and then the number of stories, I'm actually just designing a beam, so this is not a building, so I can just make this number of stories 1. I'm going to leave the story height, the bottom level, the bottom story height and all this. I'm going to leave it just as it is. Okay, I will now click on OK. Okay, it's actually still loading. Now you can see Etabs, you have 2 windows. You have for your plan view. If you look at this here plan, then you have one at this side, which is your 3D view. Then you have your model explorer here. Whatever you model here, the properties for this model will actually be here. You can actually play with all of the properties along this on this window. Okay, so now you can see on our plan view, based on our grid which we have specified, you can see is 6 meters from here to here. From here to here you also have 6 meters. So I'm going to actually switch this to an elevation view. It is actually on a plan view right now as it is. That means you are actually looking at it from the top. So to view it from an elevation view, I can switch it. This here, this is what because you can see this is highlighted. If I click this is highlighted. I can switch this. Okay, but I want to switch this one to an elevation view, so I'll click on elevation, take it to 1. Okay, if you come back to your diagram, you can see this is the elevation we want to see across this. Okay, if I switch it to this, you can only view across along this. Okay, now let's go back here. If I click on 1 and I apply and I click on OK, now you can see what we have. We have 2 spans. You can see here the base. This is the story 1. We'll go into that proper when we are dealing with a real building design. Okay, so the first thing I'll do is go to my draw, and then I'll come to my draw beam / column / brace object. So I'll click on draw beam. If I click on this and then I click at this point and I drag and then I drop here. Okay, sorry, I think there is a mistake somewhere. This is actually not straight, so I delete this. You can highlight it and delete. I'll go back to my draw, click on draw, I click here, sorry about that, I'm not really getting this right. Okay, I want to pick it from the origin. Okay, good. Now I drop this here. Good. and then I'll right click and I click on enter. Okay, now you can see automatically it has actually generated a support for us, which is a hinge support. But if you can remember from our diagram, we have a roller support at the midpoint here. So to actually change this support, I can just click at the intersection between this axis and also this beam that goes across this. If I click on that and I go to assign, and I'll come to joint and I click on restraints. Okay, now you can see we have different kinds of support here. Okay, so this is actually my roller support. So I click on my roller support and I will apply and I click on OK. Okay, good. Now you can see the roller support here on our model. Now the next thing I'm going to do is to actually impute my loadings on these beams. Okay, normally when designing on Etabs, you're supposed to define your sections, define the properties, the materials, okay, on your members before going into analysis and design. Okay, but since this is actually just a beam that we are actually designing, so we will not go into that, but later on in this video, in this series, you're going to see where we are going to pick a live project and then design that, doing all of that here right now. Okay, so this is actually Etabs version 19. If you have not been familiar with this, this is just how the window it's like. So if I click on this member and I come to my assign, I'll go down to my frame because beam is actually a frame. So if I click on point, now at this window you can see the load pattern names. Okay, we have for dead load, we have for live load. Okay, so this is now here at this point we are going to use relative distance from NI. Okay, on the next tutorial I'm going to be showing you, on the episode 2 I'll be showing you how to use absolute distance from NI. Okay, so we are going to be using this later on, but on this I'm going to be using relative distance from NI. Now what this means is that at this end here it is called the I. Okay, this is an N. At this end here it is actually our I. Okay, so the span from here to here is actually assumed to be 1 meter. Okay, using this relative distance. Okay, so it is assumed from here to here to be 1 meter. So to get the midpoint, sorry, I did not specify this, so this is actually 3 meters. Okay, so this is 3 meters. Okay, good. So from here to here it's actually 1 meter assumed. Okay, so to get the midpoint of 1 meter it's actually going to be 0.5. okay, so 0.5. okay, and then the load is actually 10 kilonewton. Okay, sorry, I did not impute this load. So let's say here we have 15 kilonewton. Okay, so here we have 10, and then the direction of load application is by gravity. Okay, so I'm going to leave everything here as it is right now, and then I'll click on apply and then I click on OK. Now you can see our load is actually at the midpoint of this span. So I'll click on this span and I'll come to assign, and I'll come to my frame load and I'll click on point. Right now I'm going to be using absolute distance from I. Now absolute distance is actually going to use the actual distance, okay, from your eye. Okay, so the actual distance which we specified here from our diagram is actually 2 meters, but you know from here to here is 6 meters, so this is actually not at the center. So I'll type in my 2. Okay, so if I type in my 2 and then I click on apply and then I click on OK. But before then, now you can see we have replace existing load, we have delete existing load, we have add existing load. Okay, let's say for example here we have, you can see this load has already been there. Now let's say for example here we have okay, let me just particularize this, and then here you can see it is 10 kilonewton. Good. Now from our diagram we have 15 kilonewton. So what I will do, if I want to replace existing load, I will just type in 15. Now I already have an existing load which is 10 kilonewton. So if I click on apply and I click on OK, okay, I've not selected that beam. Okay, so you must always select first. Okay, so if I click on apply and then I click on OK, now you can see the value here has actually changed. Okay, let me go back there, joint, frame, point. Now I have add to existing load. For example, I also want to add maybe like 10 kilonewton or 5 kilonewton to the existing load that is actually here. Okay, once I add, you will see that value here. Let's say and make this true. Okay, and then I click on let's say at the distance of 3 meters. Okay, and then I click on that span and I click on apply and then I click on OK. Sorry sorry, I forgot. I was supposed to click on add to existing load. Okay, but there is no problem. I'll just make this 15 and then I'll make this 2 meters. Okay, so if I click on add to existing load and I click on apply and I click on OK, I need to select that beam. I do forget that. Okay, so I apply and then I click on OK. Now you can see it has added another load for us, and as well I can also delete the existing load that I have here. Okay, after I've done this, the next thing I'll do, I'm just going to save this work. So if I click on Ctrl S, now you can see it has taken me directly to my document. It is advisable you create a folder specially for this. You can see I just right click and I click on new folder. So if I make this Etabs, now Etabs actually generates a whole lot of files. So you may not want these files to actually mix up with your other files. So so whatever I'm going to be designing right now is actually go into this folder. So if I make this beam design, and then I save. So my work is actually now saved. So the next thing I'm going to do here is to analyze. Okay, I can analyze this building, this model. Here you can see we have run analysis. Okay, so I can run this analysis. Okay, can see here also we have the run analysis, so you can either do it from here or you come to analysis and you run your analysis. So it is actually running the analysis for us right now. If you like what you're seeing, make sure that you give it a thumbs up. Like this video and give it a thumbs up. Subscribe to this channel is 100% free. Okay, click on the bell icon so as for you to always get a notification whenever I post videos like this. I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Now you can see here, if you read this, you can see run tag 0, run serial 1, operation running analysis, load cases, solving linear stiffness from 0. Okay, initial conditions, the structure is unstable for ill conditioned. Okay, check the structure carefully to obtain further information. Okay, now it's actually giving you information about the structure which we just analyzed. Okay, firstly, you can even see the span itself is actually 6 meters, and then at this point here we have 2 pointed loads. Okay, so but as you can see from everything here, and again we've not defined the section of that member and all that, so you can just go through this before going into anything. Now you can see the number of errors. We have 0 errors. That means everything we did, actually the steps is perfectly okay, but we have warning, okay, which is actually here, which is warning us, okay, about what is going on. And then on the member itself, you can see the information here. We have 2 informations. These are for the information. This is actually the information 1, this is the information 2. Okay, it said mode sort reduced to the number of mass degrees of freedom. Okay, now you can see this is the information 2, and then this is actually the warning is actually giving you. Okay, good. So I'm actually going to click on done. When we go proper into the building designs, we're going to see how we can resolve all of these warnings and informations which is actually giving us. Okay, now if I click here, you can see the displacement here on this member. We can as well view the displacement on this our elevation view. Okay, all I need to do is just to go to display, and then I click on deform shape. Okay, so I'm going to leave everything here as default, and I'll apply, and I'll click on OK. Now you can see the deformation here. You can see here because we have 2 different point loads. Okay, one at 2 meters and another one at the midpoint. Okay, here we only have 1, so you can see the deformation here is actually not as high as the one that we have here. Okay, so this is your displacement. Now if you come down here, you can see we have displaced frame. Okay, here we can see our shear, and we can see our moment. Okay, and the bending moment on this member. Okay, so let's go into that. So if I click on this, this is actually the shear 22 is actually for your X, the shear 33 is actually for your Y. Related to that, similarly, this is for shear 22, moment 22 is for your X, moment 33 for your Y. You want to see your torsion, your axial force, okay, any of this member, all you need to do is just to click. So to see for this shear, okay, I will apply, and then I click on OK. Okay, so you can see, and then as well we can view the value for this shear, so we can see. So if you click on show values at controlling stations on diagram, I click on apply, I click on OK. Now you can see the values. Okay, Now good. So what if you want to see the moment, I'll click on apply. Okay, now you can see your moment diagram, okay, on this member. Okay, can close this. So force/stress diagram, if you come here, what we saw here, you can as well come down here under your display to view your frame, just like what we did here. Okay, it's actually very similar, so it's actually the same. Okay, so you can achieve it in both ways. So if you like what you're seeing, make sure that you stay blessed, make sure you stay safe. Okay, make sure you subscribe to this channel because it's actually free. It's 100% free. You can come register with us on our Telegram platform where we'll train you, we'll guide you through the process of design. Make sure you stay safe and make sure that you actually stay blessed.